Hello everyone and welcome back to another episode. We're going to be continuing beaconing up these existing ones. We're going to continue with the circuits. Now this one's probably going to be the hardest one to do, so this is what it looks like normally. Alright, so the first step would be to just probably remove... Well, let's turn all these to tier 3s. Interesting. Well, let's start... Can't put them there. Let's just start putting them here and see if I can easily make this work. Because if this works easily, maybe I'm a fool and it's the others that'll be hard. I can just move this back one. And let's add speed modules to that. Okay. Now, and this gets those two. Oh, that's very good. Hold on. Oh. Uh-oh. Uh-oh. Not working. Actually, we'll keep those. Get rid of these. Get rid of these. So. Maybe extending it over one? Like this. In the middle, it doesn't work. Bummer. They're 3x3. I think last episode I said 2x2, but they're 3x3. Well, they're way more than 3x3, but they affect 3 tiles out in either direction. So... I mean, I could stretch this out. Or I could look at a different way of doing it here. Maybe... Can't go in there. Well, the goal is to produce a blue belt, so it doesn't even necessarily have to be this big. So let's actually take a real close look at the individual modularized unit. So this, okay, so this middle one's always going to be slightly awkward because if they'll never be uniformed, they'll have to like alternate by one tile. Because if I move this one back, then it'll never reach that one, and then this one will never reach that one unless I push it one more forward. So, well, let's see how many, yeah, let's do the whole thing. Only 2 per second? It's because there's no power, right? If I were to give these guys power, that would change. Yeah, 23. Okay. Wow, that's really fast. 27 to 23. 15 to 13. So 30 to 26. 30 to 26. It's like the same. It's the same ratio. Because it should be. Actually, it should be better. Because I have more productivity modules. I mean, that could work, right? Maybe that's the way of doing it. I think this is the way to do it. This looks like it'd be just fine. Now this is, let's see. This is powered. Okay. I don't need to look at that anymore. I noticed when I was editing the video that these also didn't have speed modules in any of the others other than the first one, so I changed that. I think it all still worked out. No, it worked out in the end. See, now I'm consuming my 1.5, which is what I originally wanted to get my 15 per second, and this works great here. Go away. Yeah, just wanted to let you know in case you were looking at this and wondering why there were no modules in any of the others. There are. The calculations still all work out. Okay, back to this. Excellent. Let's take a look at this. Consuming tons of copper. All right, well, let's look at the an individual unit. It is producing extra copper. It's consuming way more, so these now need to be... Well, they need to be stack inserters. 2 is a red belt. Okay, so if I take these 4, it's 47. So I can literally... just use 2 of these. Like this. And in fact, it'll be interesting to notice, let's see. Whoop, there we go. Okay. I'm consuming 54. Probably gonna drop down to like 52. And this is gonna drop down to 45. So it's basically blue belt from there. And very quickly 11. It's a red belt from here on out because each one of these adds 12. Okay. So 12, 24. There we go. 12, 24, 36, 48. Essentially. Now if I were to delete these... Oh. I didn't do it up here. What does that do? I like my tier 3 efficiency modules. I want to see this. 21. So if I doubled this in size, it would still go down to... It would go up to 42. It still wouldn't be 44. That's unfortunate. But the pollution, it would only be plus 8%. Power wattage would be 280%. A lot more manageable, technically speaking, for PowerPoint wise. Because this doesn't show power. Well, let's add one more and see what happens here. This would be red belt. Get 34. And now we are at... Oh, we're at 47 again. So I can't math, apparently. Why did I think that would be... weird. 47, same ratio. A little bit longer. Is this more power efficient? Is this more pollution efficient? I don't know, because I'm not doing this in Hell mod. I'll spend a couple minutes here to try and figure it out. We'll do that. Okay. We are obviously going to be using those. And now what I want to change, product, 45. Haha, I figured out a better way rather than changing the percentage. I am very proud of myself. 8, 9, and 2. 54 megawatts. Okay, so this is kind of what I'm after. Now, the 8 machines, does that make sense? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Yes, it does. Now, if I change the beacons... Probably this number changes the amount, but yeah, interesting. If I were to put 4 in there and do the same ratio, and also the same ratio for these guys, it goes up to 14. So we went from 8 to 14. I'm using 47 megawatts of power. There's my pollution. I forgot what that was originally. Bummer. I'll have to change it back. But I see 14, so 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 13, 14. So technically I don't need these bottom ones, which is fantastic. These can go away. There we go. Last one. Wow. Double the pollution. So I think I have my answer. Just build more machines. Machines are cheap. Oh, the modules are super expensive though, aren't they? And I would be increasing the amount of modules I have by a lot because I'm nearly doubling the amount of machines. So it's a time thing, kind of. How important is the pollution? Let's see here. Processing units, big electric motors. The vulcanite blocks, more processing units. More processing units and cryonite rods. I think I just full send it again, and I just build better defenses. Which is what I was already leaning towards. Since this is so short. I was thinking of taking this and just sticking it up here to make it longer. Let me hold that thought. Let's go over to red circuits, because this is this is really freaking long. And if anything, this should now get shortened. Just to straight up shorten. And I did not leave enough space. I guess I'm gonna force myself to put it on the inside. Oof. Technically I can do that though. I'll figure out a way. Yeah, it's my 15 a second currently. Okay. Well, let's just cut all this out, because this is now not important. I can go 2. And all the arms can go as well, because those are going to change as well. And all these can now go to tier 3. Excellent. And we're going to build this around beacons. So that's 3. That's 3. That's 3. Now if I bring this up one, that goes there. Now it can't be in the middle. Because it's going to want inserters. But this one doesn't need inserters on the inside. And there's not even a way to get 2 in here without them overlapping. You can get 4. Oh, is it going to be like this? Is this how it's going to be? Not quite. Yes. Yes, it is. I've unlocked, I think, the secret sauce. Okay. What if I just make it fun where I input where the belts are, where the undergrounds are, and now all the inputs actually end up being kind of in the middle of the unit. Okay. This means the output's going to be one more tile over. So it's not quite super tileable, like module-wise. Like this, I can just, you know, cut out this here and then paste it down again and again and again. Also, these mess up the number-wise because there's 4 here and then there's 4 here, but this one needs to be a coil. I mean, maybe if I built all the coils in the beginning, but F that, that's kind of annoying to change that now. And so this guy actually probably wanted it to be the same. 1, 2, 3, 4. Be here. There we go. 1, 2, 3, 4. Base. Now, could I copy paste this and then just change some of the inserters around? Probably, actually. Let's do that. So this makes 6, and I want to make 15. 1, 2, 3, 4, 5, 6, 7. Just not do that one. .6, bummer. These make half a second, so I need 4 more. There's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, we're down to 14. Right. They do need a speed thingy. Okay. And it would be there. Now it would work. Yeah, okay. I think it would still work, actually, even though there's a slight deficit. Should I test it and see? Let's test it and see. No, this is the last one on the chain. We want to make sure this guy's always working.
We can just monitor the green light here.
I'm actually using this mod. Yay. Haven't had a chance to really use the bottleneck mod because I haven't been building anything super efficient yet. But we're starting to, especially when we beacon, we need to make sure we can load and unload assembling machines as fast as possible. So this guy hasn't stopped working. This hasn't stopped working. Assuming we have constant flow of copper. It's all the way backed up down here. One's holding 3. This one will be obvious to move. Oh, did you see it? It just changed to 2. This guy just changed to 2. Alright. This one's holding 1. If it moves, we know it dropped it. This one just went down to 1. So 3, 2, 1. It's gonna happen. There we go. So that one just went. And then that one just went. So these are gonna work very, very rarely. So this works. Which is great. Alright, let's do blue circuits. The test template. The old blueprint here. We're gonna smash the beacons on the inside again, I think. Ooh. Gross. How many is this producing? 5. That's what I want out of this. Okay. We'll cut that much out. It might need to be something like that. No, I did belt weaving. Which means what I did here doesn't work. Because I need all 3 spots for inserters. So it would have to be like this, or I need to redesign it. And this is already going to have to get redesigned here. I don't think you need these lights and stuff like that anymore, though. I'll get away with these. These guys. One for everybody, huh? Interesting. It does appear to work. That means that can move up 1. Okay. So that means undergrounds are actually useful for that point right there. And neither's, well, whatever. Matter. We're gonna have blue belts on either side. No express underground thingamabobbers. Okay. That looks good over there. Do the same thing here. Okay. Now for the belt weaving. Oh, hold on. I won't need to alternate if this works. Okay, blue can go in the middle. That's nice. 3.5. Yep, and I need the space for the hands. Okay. Maybe I should build it not to an output, but to consummation. The consuming of a certain amount of material. Because I don't think I'm gonna be doing blue belts worth of blue circuits. Okay. We're way high, so let's scale it back. That's 108. Okay, let's scale it back. 99. 90. There, this is a flat. 90 and 9. To get 6, essentially. Alright, so that's what we'll do. That's the end of the line right there. Now I just need to put the inserters in. You are consuming 4.5 a second. That'll work. Let's do one, just build one section and then I can copy it over to the others. Now we need to do red circuit pickup. Okay. Yeah, it's gonna have to be here. And then output there. We'll just do that. Oh yes, okay. Now it should copy without a problem. Very good. Let's take a quick look. Let's see if I can Make this better. No power? That's a problem. There we go. Okay, so this last one is not necessary. That is, though. So now we will just actually cut all this off. Okay. These need to be upgraded to inserters. Totally forgot about that, so that needs to happen. Maybe. Because we're not, these are way overproducing, right? We're at +8, which is almost a third of their total, a fourth, a quarter. 8 goes into 32. This is 9, so 9, 18, 27, 36. So a fifth. They're overproducing by 20%. What's 20% of this number? Probably less than 45. What's 80% of 52? Probably less than 45. So I might not need this. So when I go to test it, we'll see if the little inconsistencies start to matter. Well, okay. Gaps on the other side now. These inserters can't keep up. Which I suppose makes sense because they're only should really only be able to handle 4. So if I were to change these to 3, not even all of them were changed to 2, as I just saw. But if I change them all to 3, all of a sudden, wait 10 seconds. There's a gap. This will work better when I get the final upgrade. Those are still 6. These are 3, unfortunately. Hold on, I'm not even watching it down here. Oh yes, of course. Dang it. There's still a chance that their gaps appear. Interesting. I mean, it catches some. It's not catching both sides. How could I catch both sides? That, I guess. Alright, I kind of like that. So I'll do that. Yep. Okay. Alright, I'm gonna add these, the blueprint here. That is looking pretty good. Do kind of like the looks of these builds. I'm just gonna create blueprint. I forget what I was calling it. Okay. So we're gonna do green circuit here. 45 a second. And we'll just say green. Bam. Was it the blue circuits that I tested? Oof. Let's test this. Yep, and then we need this over there, and that's going to be sulfuric acid. I totally forgot to even check how much I used. 22 a second. That seems kind of like a lot. Yep, and then I need a way for these to disappear. There we go. I just want to make sure that these machines can work, because the output is whatever it's going to be, essentially. Technically, I am consuming 90 green circuits a second. I'm only bringing in 90 green circuits a second. Maybe because the belt... Well, let's check up here. Do they stop up here? The red circuits do. But I haven't seen either of these 4 lanes of green circuits stop, so it's probably consuming all 90. This stoppage back here doesn't really mean anything. In fact, for all I know, in this underground, it could be every minute there could be 1 less green circuit on this belt. But it's close enough. 5 a second, or is it 6? Oh, sorry, that brought up an overlay that you probably can't see. My grave symbol 6 a second. And we'll say blue circuits. Now we'll put it there. Yeah, that's pretty much 6. Okay, like that, and then stack inserters. Go in 1, out 2. In 1, out 2. This is getting kind of long. It's 11 o'clock at night. I'm gonna have to edit this. I'm gonna edit this and upload this Wednesday morning. Whoops. There we go. Reaching down. There we go. One more. Oh yeah, look at that go. And we waited a while for this, I remember. It is working. Which is excellent. So I'm just gonna go ahead and kind of take this now. Get rid of the bad stuff. We'll call this 15 second. And we will show a picture of a red chip. And there we go. 15, 45, 15, and 6. Beaconed. Fully beaconed. I guess, what's the next episode going to be on? Do I get back to the mall? I guess I get back to the mall. I don't need these. Oh, we're just going to put these into there. And I think I will see you guys in the next one. So, thanks for watching. I think I'm going to work on the mall. Next episode, we'll go back over to the planet, my actual save file, and go from there. Bye-bye.